Okay, so in this video, we are going to talk about decaying. And in this case, there is some radioactive material called polonium-210, and it has a half-life of 140 days. So what does that mean, half-life? So it says half-life equals 140. So let's take a look at what happens. So in the beginning, I will just say that the mass M0 of the substance is 770 milligram. So when it says half-life, what that means is in that time, in the 140 days, it's going to be half left. So whatever is 770 divided by 2. So if you were to just open a calculator and divide it, so you would get 770 divided by 2, that's 385. So that's your new amount going to be. So we need to find this value of K. So we got mass M equal to M0 multiplied by e to the power KT. That's the formula. Okay, so we know that the original mass was 770, and we know the new one is half of the original one, which is 385. And we also know the number of days, so that could be substituted into T. And we need to solve it for growth constant. So step number 1, isolate the exponent. And we do that by dividing by 770, which was the initial amount. We're dividing that both sides. And that will isolate E term. And then on the other side is some 385 divided by 770. I'm not going to mess with that yet. So the next thing is to apply natural log to both sides. And when you apply natural log to E, what happens is whatever was in the power will jump in front of the log. So this K multiplied by 140, this part will go in the front. And what will be left is natural log of E, which is just 1. So we're going to get natural log of 385 divided by 770 equal to K times 140. And finally, the last step in solving for the growth constant is to divide it by 140, which was that half-life. So we have the formula for the K, growth K, is log of the 385, which is like the new amount, divided by the original amount, and then that whole thing is divided by the half-life. So whatever is the half-life. So that's the formula for the growth constant. Anyway, okay, let's go ahead and substitute what we have in the Desmos calculator. We're going to clear everything. Looks like it's already cleared. Okay, so we're going to get log the new amount, which was 385, divided by the original amount, and then divide that by the half-life. Okay, so this is the growth constant. Now it says 6 decimal places, but I'm going to save it in K just in case, because if you just change it just a little bit, sometimes your answer will be wrong because of rounding. So looks like I'm just going to highlight the 6 decimals, and the next number after that is 0. So that should be it. Okay, so that's the constant K. My next step is to plug in 1 year to figure out what would be the new mass. So I'm using 1 year, plugging that for T. So the original amount was 770, multiply that by e to the power kt. Now t here, so that's one thing that you need to watch out for, because it says 1 year. T is actually going to be 365, right? Because t is in days. Okay, so that gives me about 126.4, something like that. Okay, finally, I will need to solve how long will it take for the sample to decay to 538 milligrams. So the 538 milligrams is a new mass. The original mass again was 760, and then we got e to the power k, which we know, that it's this long number. Sorry about that, I just messed up on one of the zeros. So this is going to be 4951. 4951, and then multiply that by t, and we need to solve this for t. So again, the same process will follow, which is dividing both sides by 770. Once we do that, it'll cancel on this side, and then we apply natural log to both sides. So this is going to be natural log of 538 divided by 770. And then when we apply natural log to e, it'll cancel, and whatever was in the power will jump to the front. Finally, we will divide both sides by that growth constant k to find the time. And that will be done on the calculator. So let's go ahead and do that. So we're going to plug in. So we've got log of the new amount divided by the original amount. And then we divide the whole thing by k, which is the growth constant. So 72.4 looks like is what I got.